What's up everyone, Patrick here, welcome back. Moving on to the next question. This one's going to be kind of tricky, it's fairly unique. So we have to solve for x and y in this system here by elimination, and then we have to state any restrictions. So notice in this case, we're actually not dealing with any numbers. So we have the x and y variables, and then the coefficients are letters A, B, and then we have the number here, C, coefficient D, coefficient E, then we have a number F. Okay, but the same process is going to apply like we have numbers. So what we want to do is we want to first make sure that the coefficient in front of either the x's or the y's is going to be the same, and then we could eliminate those. So what I'm going to do, it doesn't matter which one you decide to eliminate, I'm going to eliminate the x's. And so right now we have ax minus dx, right? We can't do anything there to eliminate these. These are different, right? It's almost like, let's say a is 5, so we'll have 5x minus 3x. Let's say the d is 3. Well, this would just end up equaling 2x. We want it to be 0x. And so what we want to do is multiply this by something and this by something to make them the same. And what would we multiply this by? Well, we can multiply by the d value. So we can multiply all of these by the d value. Remember, what we do to one expression, we have to do to all expressions on both sides. And then this one we can multiply by the a value, like that. And so what's going to happen then, d times a, I'm going to put them in alphabetical order, so that would be AD, and we're going to have x. Okay, so remember, these are just coefficients. You treat these like numbers. The x is the variable. And then we'll have plus b times d would be BD, that will be y. And then we'll have CD over here on the right side. With the second equation, a times d is AD. And then we'll have x plus a times e is AE, it's going to be y, and then we'll have a times f, which would give us AF. And so watch what happens here. Now we subtract because these are the same, right? And so those are going to cancel out. We'll end up with just 0x, so we don't have to write anything. And then over here, I'm actually going to keep these separate for now. So I'll have BDY minus AEY. And then these I'm going to keep separate. Actually, we have to keep them separate because they're not even like terms. So we actually don't have a choice in the matter. Okay, so this minus that ended up being 0. Then we have this minus that, and on the right side, this minus that over there. Now, what are we usually doing once we get here? We're isolating for the y. The problem is that the y value, it's in both of these expressions. So what we can do is we can actually take out a y value. We could factor out a y, and we'd end up with BD minus AE in brackets. Okay, so it's like doing the distributive property but backwards. So if we took this and distributed the y to this to that, we would end up with that. Well, now we're going backwards. We're taking the y out, and we're just left with BD minus AE. We're just left with that bracket right here. And now to get the y by itself, all we have to do is just divide by what's attached to the y, which is this. So we would divide both sides by BD minus AE, divide this by BD minus AE, like that. And so these cancel out, and so the y value ends up being this expression right there. So we'd end up with CD minus AF all over BD minus AE. The whole y value is going to equal this right there. Okay, another format that you can see this in is you could switch these up. So how to explain this? Let's say we have a fraction, right? We got 3 over 5. 3 over 5, notice if we multiply the numerator and the denominator by the same amount, 3 over 5 is the same as 6 over 10. Or if we multiply these by, let's say, I don't know, let's say 9. Multiply this by 9, 27 over 45. This, 3 over 5. They're all the same thing, as long as you're multiplying the numerator and the denominator by the same thing. Another thing you can multiply it by, which is what we're going to do here, is you could take 3 over 5 multiplied by -1 by -1, which would be -3 over -5. 3 over 5, -3 over -5, those are the exact same thing. And so another format you might see this in, just in case this is a multiple choice test, is if we multiply this by -1 and this by -1, the -1s we have to actually distribute because there's multiple terms. We're multiplying that whole thing in brackets by -1. So we would have -1 times CD, which is negative CD, and the negative turn into a positive. Same thing down here. And then we'll have AF minus CD over AE minus BD. So you might see this as well. This and this, they're actually the exact same thing. Okay, if you could see this with numbers. So let's say we have 5 minus 3 over, I don't know, let's say 7 minus 2. Okay, what would this equal? It'd be 2 over 5, right? But it would be the same as 3 minus 5 over 2 minus 7 if we line these up. It's kind of like that slope formula where it doesn't matter which coordinates we label x1, y1, as long as they're lining up. x1, y1, x2, y2. Notice here we'd end up with -2 over -5, which would give us +2 over +5, which is the same as this. Right? So you could switch these. Okay, so y can be this, or it could be that. Both of these are the same thing. Just in case this question maybe comes up in a textbook, it's a fairly popular question, right? The solutions may give this format, or they may give this format. Both of them are the same thing. So I'm actually going to just keep both formats written. Okay, so y can be that, or y can be that. Now that's just the y value. Okay, that's just the y coordinate. We have to solve also for the x coordinate. Now usually what we do, this is usually a number, right? So usually what we do is we take that number and we plug it into one of the equations, whichever equation we've made, or the originals, to get the corresponding x value. Okay, but notice that in this case, that's going to be a crazy headache. If we take this expression for y, if we plug it in here or plug it in here, doing all that algebra to solve for the x value is just going to be way too much. And so to get the corresponding x value, what I recommend doing is actually just doing the elimination again. But in this case, just eliminating the y values and then getting the x values, right? Instead of, again, taking this, plugging it in here, or plugging it in there, and then isolating for that x, doing all that algebra, it's just going to be a headache. What I recommend, again, let's get the y's to be the same, and then we can subtract everything again, doing elimination, to just have the isolated x value. And so to do that, we have by and ey. So those are not the same. They're not going to cancel out now, but notice the b we can multiply by the e, and then the e we can multiply by the b, and then they'll be the same. But if we multiply this by the e, we got to multiply everything by the e. If we multiply this by the b, we got to multiply everything by the b. So we'd end up going in alphabetical order here, a, e, x plus b, e, y is equal to c, e, like that. Then we'll have b, d, x plus b ey is equal to bf. Like that. Let me just make sure that we're all good here. Yeah, looks all good to me. And now notice these are the same. So we can subtract this second equation from this one. These are going to cancel out. Let's keep these separate. So we'll have AEX minus BDX like we had before. And then CE minus BF like that. And then same process, we want to take out, factor out the x to get it by itself because there's two x's here. And then divide both sides by this bracket that's attached to the x. This here is a number. Remember, all this A, E, B, D, C, F, these are all numbers. So 2 numbers multiplied minus 2 numbers multiplied is just going to be a number over here, right? It's just a little bit more algebraic work because the numbers are represented by letters. But the same sort of intuition applies, right? Whatever number's attached to the x, we divide both sides by that number. That cancels out. And then x is just equal to that. So x is equal to CE minus BF. Just want to make sure that we didn't miss anything here. Yeah, it looks all good. So then we'll have over AE minus BD. Like that. And again, we can switch these like we did before. We can multiply this by -1, multiply this by -1. So you might see another format be BF minus CE over BD minus AE. So either of these for the x values, either of those for the y values, and a combination. It could be like this and this, or it could be this and this, right? So just be careful, especially if this is like a multiple choice. Any of those formats can come up. But if we represent it with the original 2 that we got, the x value is CE minus BF over AE minus BD. Sorry, that's just the x value, right? Comma the y value, CD minus AF over BD minus AE. And maybe it might be nicer to put this for the y value to keep the denominators the same. Or maybe put this for the x value to keep the denominators the same, right? They're both going to have the same denominators. But either way works. So I'll just keep it like this. But again, this x, this y can be either of these x's, either of these y's. Any combinations of those is the correct answer. It's the exact same thing. So just don't be too worried if you see another format. It's the same thing. Now, the last thing, they're saying state any restrictions. And restrictions, you're actually going to deal more with restrictions in grade 11. But what restrictions mean, usually with these kinds of questions, is anything that would make the denominator equal to 0. Because notice that, as we know, we can't divide something by 0. Right? If you take a number divided by 0 in your calculator, you're going to get an undefined value. So you can't be dividing anything by 0. And so in this format, if we plug in actual values for A, B, C, D, E, F, actual numbers, what's neat is actually you could just plug in the values here and those are going to be the solutions. It's actually a nice way to kind of plug in random values, solve the system, and then see if these work out. And they actually will work out. But the only thing you got to be careful is that this final solution, the denominator is not 0, because then it's going to be undefined. And so the restriction is that what would make this be 0? Well, if this and this are the same, right? If we have like 5 minus 5, that's going to be 0. So basically the restriction is AE cannot equal BD. Same thing here. This can't be that, right? BD can't be AE, right? So that's the restriction, because that would make the denominator 0, which would make all of this undefined. So no matter what values you plug in for A, B, C, D, E, F, whatever numbers you're plugging in here, you just got to make sure that A times E does not equal B times D, because then it's not going to work out. All right, but if you do plug in numbers and then this doesn't happen and you solve the system, you would see that this and those actual numerical values that you get would be the same. So it's kind of cool how it works out. All right, so that's the point of intersection. That's the restriction.